Hey guys, we're going to start off today with number 1. So we're asked to find the average value of this function over the interval from 0 to 2. So we can picture a rectangle that's 2 units wide and f of c units high. F of c is what we're solving for. That's going to be our average value. The area of that rectangle should be equal to the integral of this function over this interval. So we'll integrate from 0 to 2, this whole function. This is easy enough to do with a calculator, but this question is definitely a non-calculated question, so be sure you can do this one by hand. You would use u substitution, making u x cubed plus 1, which means you need there to be a 3x squared. So it's a good thing you have at least an x squared out here. You're going to fudge and fix. And then you see you just have the square root of u. Everything else turned into du. Now since I went ahead and turned everything into u, I'm going to change the bounds also. If you're going to change from x's to u's, make sure you change the bounds also, so that way you don't have to go back to x's at the end. So if x is 0, that's the same thing as u being 1, and if x is 2, that's the same thing as u being 9. Now I can go ahead and integrate this, u to the 3/2 times 2/3. Plug in 9, we're going to get 3/27/54. That's stupid. How about just 18? Minus 2/3. So we have, I'll just distribute the 1/3 to make this easy. 6 minus 2/9. So 54/9. Sorry, 52/9. And don't forget to divide by 2 because we're solving for f of c. I'm going to pop up over to here. F of c is going to be 26/9. And there you go. All right, here we are with number 2. It's a whole lot like number 1, except I don't really know explicitly what the interval is. I just know that I only care about the section of this graph that's in the first quadrant. And without a calculator, yeah, this is a no calculator question. We're going to just have to think about this and figure out what part of it is in the first quadrant. I know it's an upside down parabola because it's a minus x squared, and we can solve for the x-intercepts easily enough if I just set it equal to 0. So I know it's an upside down parabola that goes through at 0 and again at 3, so it's doing that. So I'm pretty sure the interval is going to be from 0 to 3. That means we have a rectangle that's 3 units wide, f of c units high, and the area of that rectangle should be equivalent to the area under this curve, from 0 to 3 under this curve. This is easy enough to integrate. Minus 0. Just to make the math a little easier, I'll go ahead and divide by 3 at this point to make this 9/2 minus 9/3. And there you go, 3/2. Okay, we've got another non-calculated question here at number 3. We're given a velocity function And we're also told that at t equals 0, the position is 4. So what is the question? What's the position function? So our goal is to find x of t. We're going to integrate this. And then you just have to use the one known fact that you have to figure out what your constant of integration is. So I know that if I plug in 0, obviously I'm going to get 0 minus 0 plus 0, c, and I know I should get 4, so that tells me that c equals 4. So x of t must be t squared minus 4t plus 4. And that's number 3. Okay, number 4 is a whole lot like number 3. We have a velocity function. We're told that this thing is moving in a straight line. Of course, that doesn't mean it can't be moving back and forth. And we want to know how far it can travel between t equals 0 and t equals 2. So we're just asked for the distance traveled. So you do have to be careful about if it does turn around and not just calculating the displacement, but actually the distance traveled. Although that's not going to be an issue for us because e is a positive number, so no matter what we raise it to, it's always going to be positive. Therefore, velocity is always positive, therefore it's always moving forward. So we can just integrate the velocity function from 0 to 2 and find the displacement, because that's going to be the same as the total distance traveled since it never turns around. Integral of e to the t is e to the t. Integrate from 0 to 2, so we get e squared minus e to the 0th, and be careful that it's not 0, that's e squared minus 1. And there you go.
All right, let's talk about number 5. We have water getting pumped into a tank at this crazy rate in gallons per minute. And we had 800 gallons in that tank at the very beginning. So we want to know how much water is in the tank after 20 minutes. Okay, well, if we integrate the gallons per minute function, then we should get just regular good old-fashioned gallons. So let's integrate that nasty function between, I guess, 0 and 20 minutes, and we'll find the change in gallons. I already graphed our function here. This is the rate function, and we are going to integrate that thing from 0 to 20. Great. 0 to 20. There we go. 420. And I'm guessing that's an answer. 420 is a good wrong answer. Remember, we started with 800 gallons, and the net change is what we just calculated. The net change is 420 gallons. So we actually wind up with 1,220 gallons. Don't forget to apply your net change to an initial condition if you're actually asked for a value and not just a change. Make sure you apply your net change to a value that you have. Okay? There's number 5. Okay, here we are, number 6. We have an acceleration function, another ugly one, and we are given a specific velocity at what? T equals 1, and then we're asked for the velocity at t equals 2. So this is a lot like number 5. If you integrate an acceleration function, you're going to find the net change in velocity. So just integrating that function from 1 to 2 will tell us how much the acceleration changed. Sorry, how much the velocity changed from 1 to 2, whatever units they are. So let's just integrate 1 to 2, and there you go. The change in velocity from 1 to 2 is 1.35 whatever per something. So let's see if that's an answer. No, it isn't. Well, that's good because it's not the right answer. That still needs to be applied to your initial condition. So if the velocity was 2 and the net change from 1 to 2 was, whatever I just said, 1.35, and it was going 2 units per something, and now it's going to be going 3.35 units per something. So there we go. Cool. Okay, number 7. It looks like a simple find the area kind of problem. The area trapped under that curve, between that, the x-axis, and these two vertical lines. Just find the closest integer approximation for that area. All right, that's straightforward enough. So let's just graph this function. Be careful when you're graphing that in your calculator because there's no way to get the 4 like where you think it should go between the cosine and the x. You have to make sure you are raising the whole cosine of x thing to the 4th. So just be careful putting that in your calculator. I'm sure there could be mistakes there. If you don't know how to graph these vertical lines, thanks to Avanish, you can just use relations instead of functions. If it does say function right there, you can just actually back up and erase the equal symbol, and then it will give you the option to just input a relation right there. Or you can go to wherever it is, menu, graph. Oops. And go to relation that way. Okay. So it looks like we're just trying to find the area of that whole hump right there. So we're just going to integrate. It's asking me which graph because I have a bunch on here. So make sure you choose your graph. And I'm going to go from negative 2/3 to 2/3. So it's just under 1. So our closest integer approximation is going to be 1. Cool. Okay, number 8 seems easy enough to do by hand. But if we're allowed to use a calculator, we might as well. So we've got a parabola and y equals x, and we just need to find the area enclosed there. So we'll graph them, and we can actually just cheat with our Inspire and ask for the bounded area. Analyze graph, bounded area, lower bound, should click on the intersection point, and again, should snap right onto that intersection point, done. And we've got 0.166 repeating probably, and that is 1/6. Cool. All right. Here we are, number 9, and we've got another bounded area question. We just have an ugly cubic and a simple line. So let's see what that looks like. It is a calculator active question, so we're just going to cheat again with the calculator. Here's the cubic and our line, and it looks like we're trying to find that little area and then this bigger bubble, all of that bounded area. So let's see if our calculator can do that all in one fell swoop here. Analyze graph, bounded area. We should just snap to that intersection point and that one. 11.8. Got it. All right, I'm just reading over number 10 now, and I think I see the problem. This is not worded right. There's nothing up, what does it say? Above root x and below x squared. Pretty sure that's just a typo. So hopefully you figured out they just meant the complete opposite of that. In the first quadrant, you want to be obviously below root x and above x squared. So this right here, this little flower petal thing, That's going to be our floor plan, and we're going to build squares on top of that. So every side is just going to be the distance between two graphs. So from x squared down, or from root x down to x squared. So let's just pop over to here, and I'm going to do the integral from 0 over to 1. Everything's in terms of x. And one of the sides of the square is just going to be, whatever I just said, root x minus x squared. And that gets squared. If everything's squared, you just need one side length squared. From 0 to 1, we'll add all of them up, and we get 0.129er. Hold on. 0.129. There we go. Okay, number 11, we have another solid with a known cross section. And again, let's see, it does say perpendicular to the x-axis. We like that. And here is our floor plan. Everything under this parabola and above the x-axis. So every one of these cross sections is going to be an equilateral triangle. You know that formula. We are just going to set up that integral. This will be in terms of x. Pretty sure. Let me do that. I'm not looking at. Sorry. What's that going to? 2. All right, so from 0 to 2, we have the side of the equilateral triangle is going to be, what was the function? 2x minus x squared. Square that. But on the other side, we need root 3 fourths. Out of 462. There you go. 462.
All right, number 12 is another no calculator question, and I know you don't like this because there's a secant. And no one knows what the heck that looks like. But knowing what it looks like might help you out here. So if you do know what it looks like, you got lucky. A whole bunch of bubbles up here, down here, and all the way to the left and the right. This right here is at x equals pi. So you know x equals pi fourths is way over here, so we're really only talking about like this region here. So we're under the secant curve, we're between the two axes, and we're also trapped by x equals pi over 4. So there's our region right there. We're going to go around the x-axis. That means we get to use dx. So everything's in terms of x. We'll just integrate from 0 to pi over 4. And we're going to use the disk method here. So we just need pi r squared. Pi, and the radius squared. Every radius is just going to be secant x minus 0 squared. That's really easy in the calculator, but you're not allowed to use it. So you got to know how to integrate secant squared. And the integral of secant squared is tangent. Tangent of pi over 4 is 1. Tangent of 0 is 0. So there we go. Everybody's favorite number, pi. Okay, number 13 here is pretty easy because you don't have to do any math. You just have to set it up. We have the region bounded by x cubed, x equals 4, and y equals 8. Considering this is the point 464, 8's going to be way down here. All right, so I guess we're looking at that little area right there. And we're going to spin around y equals 8. So we're going around this axis, and we are going to get to use dx. So that's good. All our answers are in terms of x anyway, so that's easy. It looks like, well, the bounds are, I'm guessing 2 to 4, because that's our only option. And we are spinning around, each rectangle is spinning around itself, so we are just making discs. There's no washer. I only need one radius. So it looks like the radius is always going to be x cubed minus 8. And then we'll square that. So there you go, x cubed minus 8 squared, pi r squared. There's your formula right there. A, forgot to square it. B, thinks that you can just square the two things inside the binomial. You can't do that. That's trash. And this is obviously just addition. That's trash. Okay, there you go. C. Okay, our last question here is another fun one because we don't have to do any math. We just have to set it up. And it looks like everything's going to have to be tweaked into terms of y. And so what the heck is all this going to look like? Well, let's see. We have sine of x. That's easy enough. Y equals 2 over pi x. I don't know what the heck that is, but it's definitely a line with a slope less than 1. So there we go. We'll just call it that. And we're going around x equals -3, so there you go. We have to do all this without a calculator, by the way, because this is a non-calculator question. So this is our region, and we're going to spin around x equals -3. So without even looking at these answers, I'm going to definitely need 2 radii, because this rectangle is going to leave a big hole in the center. So we're using washer method. Pi looks like, I'm just going to guess my bounds are 0 to 1 because that's my only option over here. And the big radius is going to be right minus left. This side of the rectangle is further away, so that side is going to make my big radius. Right minus left is going to be the line minus -3. Now everything's got to be in terms of x. I'm sorry, in terms of y, so we do have to tweak these two things. Instead of using this version of the function, I'm going to call it x equals pi halves y, and this is x equals arc sine y. You kind of can't forget to do that. It's really your only option over here in all the answers. So there's a big hint. Anyway, now right minus left is going to be pi over 2y minus -3, so it becomes +3. There's your big radius, and you square it. And then we take our small radius, right minus left. That's going to be arc sine y minus -3 minus -3. Square that, and you're done. So that looks like D. Cool. All right, guys, if you have any follow-up questions at all about any of this material, don't hesitate to reach out. There's going to be another review coming out next week, so look out for that. And until then, just stay healthy, safe, and sane, all right? Have a good weekend.